Hello and welcome to today's video. Today's video is for Advanced Geometry, Chapter 11, Section 2, Surface Areas of Prisms and Cylinders. So we're going to start out with some definitions. A prism is a polyhedron with two congruent parallel faces, and the bases are the parallel faces of the prism. So I've got two examples over here, one in which the bases are pentagons, so it's called a pentagonal prism, and one in which the bases are triangles, so it's called a triangular prism. The other faces, a lot of times we like to put the bases on the top and the bottom, and if we do that, the other side are called the lateral faces. So the definitions are other faces other than the bases. The altitude is a segment that joins the planes of the bases, and if we find the length of that segment, it's called the heights. A lot of students think altitude, height mean the same thing. They don't technically mean the same thing because the altitude is the segment itself and the height is the length of the segment. We have a couple different types of prisms that we're going to look at, and we're going to look at both of these. One is called a right prism, in which the lateral edges are perpendicular to the base. So even though in this one the base is turned on its side, you notice that the base is perpendicular to the lateral edges. So it is a right prism. And the other one in which the lateral edges are not perpendicular to the base, and it's called oblique. Now, so we don't have to write it over and over again, right prism, right prism. In any problem, unless you are given that it's oblique, you may assume that it's a right prism. So we're going to look at two areas. One is the lateral area, and then one is the surface area. The lateral area is just the sum of the areas of the lateral faces. So if you take away the two bases of a prism, you get the lateral area. And the surface area is if you hold the figure up in space, it would be any of the exposed surface of the figure. So it would be the lateral area and the bases. And in this case, we have two bases, so it would be the lateral area and the two bases. Put those all together, you get the surface area. So we have an example here. They want us to use a net to find the surface area. I don't use nets for this problem. What I'm going to do is I'm going to show you where the formula comes from. So I'm going to change these numbers. Let's make this, let's call this length, let's call this width, and let's call this height. So if I take a look at this prism, I get 6 faces. And if I find the area of each face, I can put them together and I get the surface area of the prism. And you're welcome to do that. It takes longer to do, but you can do it for any prism. What I want to show you is how we can make a nice formula for this prism. So if you notice, even though I've got 6 sides, they kind of come in groups of 2s. The front and the back face are going to be the same, the left and the right face are going to be the same, and the top and the bottom face are going to be the same. So what I'm going to do is I'm going to go through and label them. I'll call this 1, and it's going to be the same as the back. I'll call this 2, and it's going to be the same as the left face. And I'll call this 3, and it'll be the same as the right face. Or sorry, it'll be the same as the bottom face. Now, if I take a look at the front face, the area of that is going to be the width times the height. And I've got 2 of them, so I'll put 2 times the width and the height. And then if I do the right face, I've got the right and the left, so it's going to be 2. And these are going to be the length by the height. And then if I do the top and the bottom, they're going to be the width by the length. And I've got 2 of them, so width by length. Now I'm just going to take these first 2 and I'm going to put them together. So I'm going to factor out the h, and what I get is, after I factor out the h, what's left in the parenthesis is 2 widths and 2 lengths. Well, if you look at the bottom here and you look at the width and the length, if I take 2 of the widths and 2 of the lengths, what I end up getting is just this perimeter that's on the bottom. So another way that I can write this is it's just the perimeter of the base. times the height. Well, if I'm going to call the top and the bottom bases, then this other side, 2WL, that's just going to be 2 of the bases. So I'm going to write 2 bases. And this is going to be the formula that we're going to use. What you can do is you can use the perimeter times the height to find the lateral area. And it'll do all 4 of those rectangular faces. And then all you have to do is you have to add the top and the bottom bases, so 2 bases, and you get perimeter times height plus 2 bases. And you'll see on the next page that'll be the formula. And it works for any of the prisms. So for this one, the only thing with this one is you have to turn the prism so that the parallel sides are up and down, or you need to at least think of them that way. So what I'm going to do is when I do my formula, these triangles are the bases. So the area of this is going to be the lateral area plus both bases. And the lateral area is just the perimeter of the base times the height, and that's got to be perpendicular, plus the 2 bases. And the bases are triangles, so it's 1/2 base times height. Okay. And a lot of times what I'll do, I'll write like a generic formula, lateral area plus 2 bases, and then I'll slowly substitute stuff in, and so I get a more precise formula, and then I can use this. So the perimeter is going to be the 6, 5, 5. So that's going to be 16. The height is this 12. So it's times 12 plus 2 of the area of the triangles. Now, if I'm going to, I could use trig for this, but the easiest thing to do for this is they drew the altitude. This is an isosceles triangle, so this down here is going to be 3. And if you take a look at it, it's basically a 3, 4, 5 right triangle. And so this is going to be 4. Or I could do the Pythagorean theorem. I could say that it's the square root of 25 minus 9. And so it's the square root of 16, which is 4. But if I recognize it's a 3, 4, 5 right triangle, I know that it's going to be 1/2, the base, which is 6, and the height, which is 4. So what I end up getting is 192 for this. The 2 times the 1/2 will cancel, so this will be 24. And so my final area will be 216. And I've got centimeters squared. Okay. I got one more little example here. I'll do it quickly. For this one, it's kind of nice because the triangles are right triangles, and they give you the base and the height. So for this one, the surface area is going to be the lateral area plus 2 bases. The lateral area is the perimeter times the height, and the bases are triangles, so I'll do 1/2 base times height. So the perimeter is going to be, it's a little 3, 4, 5 right triangle, so this is going to be 5. So the perimeter is going to be the 7 plus 5 is going to be 12. The height is 6. The base is 4, the height is 3, so 4 times 3. So for this one I get 72, 2 times the 1/2 cancels, plus 12, so this is 84 centimeters squared. Make sure when you do these problems that you write formulas, make sure I can see what your work is. Don't start what I call doodling math everywhere, where you do a little bit over here, do a little bit over there. It's very hard for me to follow what you're doing, and if I can't follow what you're doing, you lose a whole lot more points than if I can find your mistake, see it, and determine if it's a minor mistake or a major mistake. This one I want to do in class. We're going to talk about oblique prisms. We are actually going to find the surface area of these. They're harder to do than the right prisms, and there's a couple different ways you can do it. I have an example of a prism that you can look at in class, and so we'll do this one in class. So these are the formulas for a prism. So the lateral area of a right prism is the product of the perimeter times the height. And then the surface area is the lateral area plus 2 bases. Once you get to that point, if you want to remember that the surface area is the perimeter times the height plus 2 bases, that's fine. What I like about this formula here is it works for cylinders also, which we're going to do next. So a cylinder is a polyhedron with 2 congruent parallel circular bases. So the only difference is instead of polygons, they're circles. The altitude is also the perpendicular segment that joins the 2 circular bases, and the height is still the length of that altitude. We can have right cylinders and oblique cylinders. We won't do the surface area of oblique cylinders. We will do the volume later on, but we won't do the surface area of them. Again, if you are given a problem, you can assume it's right unless it's stated otherwise. The lateral area of a right cylinder is the product of the circumference of the base and the height. Now, I write this formula, lateral area is perimeter times height, so that it looks so much like the prism, so I don't have to remember anything. If you take a look in your book, they do break it down into, well, because it's a circle, the perimeter is going to be 2 times pi times r, and then the height is h. If you want to remember that, that's fine. But the 2 pi r is just the perimeter formula, so it doesn't matter if it's a perimeter of a polygon or perimeter of a circle. It makes it nice to remember the 2 formulas. Okay. And the surface area is the lateral area plus the 2 bases. So for this one, if you want to remember a very specific formula, the lateral area is going to be 2 pi r times h. That's the perimeter times the height. And the bases are each going to be circles. So it's going to be 2 times pi r squared. Okay. If you ever see it on like the PSSAs or anything like that, it's kind of the formula you see. Again, I like to remember this one and perhaps just plug in the perimeter times height for that one, and it makes it so it works for a lot more things. So the drum ruler at the left are cylinders of length 3.5 feet. So if I draw these cylinders so I can work with them, they're saying that this is 3.5 feet. And the diameter is 4.2. What area does the large drum cover in one full turn? So for this one, they're not asking me for the surface area because the sides aren't touching the ground. They want to know that once it rotates once, what does this roller cover? So they're asking me for the lateral area. And the lateral area is the perimeter times the height. So the perimeter is circles, so 2 pi r times the height. So because the diameter is 4.2, it's going to be 2.1. And the height is 3.5. So if I multiply these together, I get 4.2 times 3.5, 14.7 pi. And because this is a word problem, we probably should put in our calculator and get an estimated answer. So if I multiply that times pi, so I get it's about 46.2 feet squared. And that's it for today. Thank you for watching. Have a great day. Take care.